The focus of this lesson is properties of logarithms. We're going to begin with what's called the one-to-one property. This property tells us that if we have log base b of m is equal to log base b of n, this will be true if and only if m are in fact equal. For example, if I have 2 to the power of x equals 30, then we know that log of 2 to the x is equal to log of 30. And do note in this case, because log has no base shown, the base is automatically the common logarithm, 10. Okay, we're going to use this property to help us solve this problem. Example 1. Jake's goal is to have a balance of $1,000 after an initial deposit of $800. He is considering depositing money into a savings account that pays a 1.2% interest compounded monthly. Identify the time it would take for this account to reach Jake's goal. We're going to begin by recognizing how we set up our formula again. So our single deposit is B is equal to P times 1 plus R over N to the power of NT. Remember, B represents our balance, P the principal, R the interest rate, N the compounding frequency, and T the time. Let's plug in everything we have. If we read the problem carefully, we can see that B is 1,000. Our principal is 800. Our interest rate is a 0.012. We are compounding 12 times in the year, 12 times t. Ultimately, we are trying to identify the time t. Now, when we want to solve this equation algebraically, what we're going to do is start by simplifying. So I think for simplicity's sake, let's simplify the portion inside the parentheses first. Okay? So I am going to take 1 plus 0.012 over 12 and get that simplified just to make this easier for us. So we see that that's 1.001. So that gives me 1,000 equals 800 times 1.001 to the power of 12t. Now ultimately our goal is to get the 12t and t really by itself. So I want to get rid of this 800 that's being multiplied. So let's divide both sides by 800. And I have here 1,000 divided by 800, and that's a 1.25. So 1.25 is equal to 1.001 to the power of 12t. Now what I want to do is I want to remove this base 1.001 in order to get 12t by itself. Now if we look at the one-to-one property, it says that if two things are equal, then the log of those two things are equal, right? Irregardless of the base. Now what I'm going to do, because I want to remove the base 1.001, I'm going to go ahead and I'm going to take the log base 1.001 of both sides of this equation. Now do make sure that your base in your logarithm is lower than the rest because it's subscript. And then do make sure your 12t is higher than the rest because it's superscript. Now note what happens here. On the right hand side, we have this log base 1.001 of a base power, right? 1.001 to the 12t. Because these have the same base, remember, mathematically speaking, they are opposites, so they cancel each other. Now, when that happens, we are left with just 12t on the right-hand side. So I have 12t is equal to the log base 1.001 of 1.25. Okay, now I'm running out of space here a little bit, but we're going to move over to the left-hand side. So if we remember correctly from our previous lesson, we know that we can calculate this part here using our change of base formula. So that's what we're going to do. So I know that this log base 1.001 of 1.25 is equivalent to log of 1.25 over log of 1.001. We know that that's still equal to 12t. Okay, so now we're going to grab our calculators and we're going to calculate what that is. So I have here my scientific calculator and I have my 1.25 log divided by my 1.001 log, and that is equal to, it says 223.25. 223.25 is equal to 12t. I'm going to then divide both sides of this equation by 12. Let's bring the calculator back up, divide by 12, and I see that t is about 18.6. T, 18.6. And so that should in fact be the number of years it takes for this to happen. Now, the smartest thing at this point would be to check and see that that actually works, right? So for the sake of simplicity, let's get into Google Chrome. And let's actually type in what we have and see that it in fact works. So we know we had 800 at a 0.12 monthly, and we know we were hoping that it is about 18.6. And if you look here, you'll see that this is quite close to that $1,000 that we were hoping to achieve. So we feel pretty good about that. All right, now there's another property we want to look at. This will also allow us to solve the problem, but in a slightly different manner. This is called the power property. And it says if I have the log base b of m to the x, that's actually the same as x times log base b of m. In other words, this log base b of m allows the power to move from power to coefficient. Okay, so if I had log base 6 of 36 to the fourth, that's equivalent mathematically to 4 times log base 6 of 36. Now you might ask, how is that going to allow us to solve the problem? Well, let's take a look. So we're going to solve the exact same problem. So if you remember correctly, our equation is 1,000 equals 800 times 1 plus 0.012 over 12 to the power of 12t. And I'm going to skip some steps here, and I'm going to skip directly to the point at which we have our 1.25, our 1.001 to the 12t, because everything else in between is the same. Okay, so I'm going to skip some steps. Now, the main difference between this method and the previous one is that with this method, we are not going to take the log base 1.001. Really, because that's kind of ugly. It's kind of a messy process. So instead, we are going to just take the log of both sides. Now you might ask why. Well, remember before, the only logarithm that allows us to calculate directly in the calculator is that common logarithm or that natural logarithm. So if I simply take the log of both sides, it's going to be simpler in some ways. Now, if we think about what the power property says, it says if I have the log and I have a power, the power itself, right, can simply move in front. And so that's what's going to happen here. So we're going to have log of 1.25, and then in this case, that power, that 12t, is going to jump out front. Now we don't have to fuss over it, right? Now you're going to say when you look at this, the math is essentially the same, right? It's going to do the same thing as the previous one. So ultimately, remember, we're trying to get t by itself. So let's divide by everything that's not t. So we're going to divide by log and 12. Log of 1.001 and 12 simultaneously at the same time. Cancel, cancel. So all we have left is t is equal to whatever this comes out to be, right? So you'll notice that it's basically the same as the other one, right? So we have our 1.25 log divided by our, in parentheses, 12 times 1.001 log. And the cool thing is you'll know if it's going in correctly because you see it how it's being typed in here on the calculator. I did group the denominator to make sure the calculator followed order of operations. Enter, and then we get that 18.6 that we expected. All right, so we know it will take 18.6 years for him to achieve his goal at this interest rate. Now, do note that the methods don't really matter. You can choose which method you prefer. All right, so use the one-to-one property and the power property to solve for t here. Pause the video and give it a try. All right, now it's your turn to do some practice. Go to Canvas, find the assignment called Comparing Methods for Solving Exponential Equations. Once you're finished, submit your work to Canvas.